Hello, everybody.
Is the mic on?
Can you hear me? Yes. Okay.
Yes. Hello.
Thank you very much for inviting us to give a presentation here. And my name is Akim Elmling.
I'm Bas Jacobs.
And together with Sami Kotomaki, we are Underware. And yeah.
All right, so time begins at the beginning. What the beginning is, however, is not given in time, and so in consequence we must ask what happened before there was time, which is a temporal category. So what happened before there was time is a plausible question only if there is time already. But the alreadiness of time begs the question.
So if you want to export the future, it's very important to understand what time is and how time functions. And we showed this quote also last year at Typo Labs, but I believe it's always like this, that if you do something, you do it in the moment, and at a certain moment, it's going to the past, and then a couple of months later, you look at it and you think yeah, this is already defined, and you cannot say anything about it anymore. But then if you look at it carefully, then you realize that perhaps it is something else that you expected it to be in the first hand. So then only you can put it to the history. And therefore, before we start, we want to go a little bit back to last year, where we ended.
Yes, so if you didn't see our lecture from last year, you have a problem, because we're going to continue where we stopped last year. It's a triptych. So we're now 1 year back in time, and this is where we stopped last year. So we stopped at this word counter-revolution, and there were, 115 bazillion ways to display this word counter-revolution with a script typeface. If you don't, you will try to catch up. The reason was there were so many different ways to display this word counter-revolution, because there were polysemic glyphs. So you have this H and this the letter, the glyph on top, and it can be an A and it can be an H. Very simple principle what you get with handwriting, that one glyph can represent multiple letters. So if you have this for a whole set of uppercase letters, you get not 20, you don't get 26, but 47 uppercase. And if you put it for lowercase letters, you can see for lowercase letters there are not 26, but 72 lowercase letters. And all the white glyphs in here, they can represent multiple letters. And with this way, there is not one way to write the letter C, but there are multiple ways to write the letter C. And there's not one way to write the letter O, but multiple ways to write the letter O. And not one way to write a U, but 7 different ways to write a U. And it gets more complicated when certain glyph can represent 2 letters instead of 1 letter, or maybe 2 letters as well as 1 letter, or 2 letters as well as 2 other letters. If you add up all on top of each other for this whole word, you will end up with these 115 bazillion ways to write this word counter-revolutions.
So when we showed this last year, we knew that this is a very big number, but later on we were thinking how does this number relate to the language we are using? And then if you look how much words are actually existing and how much words we are using in the daily practice, you see that this is a very, very big number there on top. So if you look at this number and you look at this word, we were wondering how many combinations can be done with a more simple word, which we call the one word. And so if you look at this, at this word one word, you see there's also lots of different combinations. And altogether, it generates nearly 25,000 possible words. And this is very interesting, because we just saw that 25,000 words are already enough to communicate, because that's the amount of words people use normally. So what we showed last year was this polysemic typeface, where one word could represent 2 different things. But this year we want to go one step further, and we want to introduce something what we call a supersemic language. And this consists out of just one word. So
we call it OWL. It's the one-word language. And basically, the one-word language, it's Latin, but then a little bit with an extension of some polysemic letters. And then you get, it sounds strange, but you get to a language where you can communicate with just a single word.
So basically the script, what we are using is an extension on the Latin script. And so we use this extension, and then we just create our words. And this is like this one word, and then we just write it in 25,000 different ways. And in that way, we have like our own language. And to understand this language, you just have to do a very simple thing. You just take another language, like English, for example, and you just have to map the words one by one.
Yeah. So if you have the English dictionary, and then you put the one-word dictionary next to it, and it's very, you just have to learn a little bit, and then you see the is one word written this way, and of is one word written in another way, and is one word written in another way, and to is written, again, one word in another way. The logic is very simple. So if you take this Latin text, so in the beginning was the word, and the word was with God, and if you would translate this to one word, it would probably look something like this.
So this is a real OWL. So we have a little application where you just give English, and it gives you like the translation in OWL. And then when we did this, like we showed it to some people, and then they were wondering, like, why do you do that?
We said that's not a question, of course.
But I explain now why we are doing that. So if you have a sentence like this in Latin script, and we translate this to OWL, we get this. And everybody who can speak a little bit of OWL with a dictionary, he can translate that back with a retroscription into English. But because OWL works a little bit different than our normal language, this can happen. So you see that the sentence, the original sentence, already changed a little bit. And if we change this again back to OWL, we get this translation. And if we do a retroscript with this again to Latin, we get this. And if we do it once more, we get this. And at the end, we get this. So what this means is that actually this, what you see here, is just like a single text. But what you see here is not a single text, but that's like the world's library. All the books which have been written and all the books which will get written.
As long as you translate and retro-translate everything forward and back again, you will end up with any possible text. You can imagine with just one word.
So it's somehow the library of Babel. And then if we look again at this dictionary, you will see that it looks a little bit dull because the words are rather long, this one word. Yeah. And if we zoom in, we can see that there is lots of things in this one word which are identical in all the one words. So what we can do is actually everything what is identical, we can just skip. And then we have this. So if we have this, that's OWL for the starters, for the beginners. And then this is OWL Pro.
Okay, that's for more advanced readers. Something else. Which character is this? Probably everybody recognizes this character. Oh, it's equal sign. It's not an equal sign, it's a double hyphen. And in case you've never heard of a double hyphen, sometimes it makes sense if you take the Hamburg Express. You're not taking the train from Hamburg to Altona to Copenhagen, but you take the train from Hamburg, Altona to Copenhagen. So there you can make a difference between the hyphen and another hyphen by using the double hyphen. We didn't invent this, it exists. There are dictionaries also using this to make a difference between, for the same purposes, you can also use it in a dictionary. So this is what we call what's called a double hyphen. No.
And it's also interesting that Arno Schmidt, a German writer, he used this quite extensively in his books he wrote. And there's this famous book called Zettelstraum, and there you can see like that how he uses this double hyphen. So here, for example, you see the double hyphen, and if you look closer, you will also see that this is different than the equal sign. And if you look further at this page, you can also see that he also used this kind of polysemic language. It's a very, very interesting book. And that's him. And at the same moment, it's also interesting to see that the double hyphen is perhaps even older than the equal sign. Because, you know, the equal sign was only invented or introduced some 500 years ago. And what you can see here is actually the first appearance of the equal sign. And it's very long, and it should like symbolize two parallel lines, and they had to be so long to make it clear that those lines would never ever touch each other. And here we have a translation of the text. So it appeared in 1575, and those lines are also called Guillemot lines. And so it's interesting to see this relation between written language and math and all those different signs we are using. And if you look a little bit like more into history, you will also see that shortly after that, it was Descartes who also introduced the idea to use letters to represent variables. And there he said, like, okay, ABC should be used for static, and X, Y, Z should be used for functions. So that was shortly after introducing the equal sign.
No, you're on the route. Go ahead.
So in that way, you could also say that ABC is somehow representing the static fonts, and XYZ is perhaps more representing what we are facing at the moment with the transition to variable fonts. And if you look further again, you will also see this conjecture, the ABC conjecture. And that interesting thing with this formula is that it was very difficult to solve, and only recently, I think 3 years ago, it was solved by a Japanese mathematician. And he uses his own theory for that again, but this is so complex, this theory, this language of the theory, that until today it could not be proved if he was right or not. So in that way, it's always very difficult to understand like how characters and how signs, how they relate with each other.
So basically, that's what we want to talk about today, is how things are related to each other. So you can have one thing and you can have another thing, but how they relate to each other is maybe more important than those things by themselves. That's the main point.
And there's also Marcel Duchamp. He also once made this formula, which is A divided by B. And then he also said, like, it's not so much about the C, but it's about the division. And also this, we can translate again to typography and replace A with alphabet and B with BCS and C with contours. And then we have to realize perhaps ourselves that it's not about so much about the C, but about the division.
So that's what we should design.
And again, this is perhaps very abstract, but to make it more simple, it's like the tools you use are perhaps also defining the way you think. And in that way, if you look, like, for example, at this sentence, and you look at it like this is a Latin script, but we can also write it down differently. We can write it down in OWL, or we can also write it down with math.
Okay, simple visualization of the past, the present, and the future. In the present, if you live in the present, it's very easy to look back on the past, so you can tell something about your current state of today because you can look back and relate to that. So we know now, okay, we have the present, and we know we have seen this and this and this already. So we're now post something. We are post modern, or we are post internet, or we are post desktop. We can be post many things because we can relate to everything which we have been to, have been there already in the past. PostScript.
But perhaps this changed recently because, you know, with acceleration, our life became like much faster and everybody is stressed. And in that way, perhaps also we are too fast to relate to the past. So probably we are already in a time where we relate much more to the future. And so we are perhaps beyond these eras which were post and arrived in an era which is pre. And in that way, it's also important to realize like how life changed between the last century and this century. Like in the last century, it was very much like this, that somebody got born and you grew up, and then things were like expected, and you continued to live. And at the end of your life, most things did not change, and those things which did change, changed as expected. And there was only very little unexpected change. And I think this is something typically 20th century. And meanwhile, we're in the 21st century, and socialists and scientists, they claim that meanwhile the problem is that we grew up and then already like when we are 30, we experience like unexpected change, and once we get older and older, there's lots of unexpected change, which makes it very hard to deal with the issues of life.
Yes, this is bad news. Or could be bad news, could be good news. I don't know, depends on your state of mind. It means that we now will have many changes coming in our lives which we don't have a clue yet that they are coming, or that they will be coming. We don't know. The only thing we know is that the changes will be coming. And if you're young, like I think my kids, they will be very used to this, like because everything is changing all the time anyway. But if you're getting older, it's not so much a challenge anymore, but it's more getting into a threat. So we're getting afraid of all these things which are changing, which we don't know that they are changing.
So that's always the problem, because those scientists who said with this context, is that there's a very big difference between if you experience change, unexpected change in a younger age or in an older age. And they say like the break point is the 30 years. Until 30 years, change is experienced as a challenge, and once you're above 30, we believe it's a threat.
And if you don't have a clue what this means, like we will give some examples, like what it could mean. We also don't know exactly what it means, but what it could mean. There's an example of a guy, Gernsback, who invented these TV goggles. And he invented TV goggles already in the 60s, and basically he didn't have the technical equipment to make it work what he wanted, what he envisioned, but he wanted to make something like virtual reality kind of thing. So he made this kind of prototype, TV goggles or TV glasses. He's also the guy who invented the term science fiction, or at least coined it for the first time, I think.
In this magazine,
in this
Amazing
magazine,
Stories.
And next to science fiction, there's also something else called design fiction, by Bruce Sterling, who coined it for the first time. And design fiction is basically that you're designing, they always talk about diegetic prototypes, that you make something now to give you a different view on the future, to show all the things which you think they are not possible in the future, you think they could become possible by seeing this prototype. So design fiction is about today getting a different view about your future.
So it's trying to import the future. Whenever people are doing something, whenever something is created, we believe it happens in 3 dimensions. So first of all, there's the dimension where we actually work what we are doing, like when we design a font, we have a program, we do the font within the setting, what we know and what we can handle, what we can work with. So that's the reality. But next to that, there's also the dimension of what we can imagine. And this is all those things which we wanted to do, but which we could not manage to do because we did not have the skills, we did not have the knowledge, but we knew we wanted to do it, but we could not manage to do that.
Yeah, we know.
And the last thing is also, that's the inconceivable, and that's the dimension we are not even yet aware of. And these 3 dimensions, there's a historic moment where Donald Rumsfeld explained those 3 dimensions very precisely.
There are known knowns. There are things we know. We also know there are known unknowns. That is to say, we know there are some things we do not know. But there are also unknown unknowns. The ones we don't know, we don't know.
Excuse me, but is this an unknown unknown?
I'm not.
Several unknowns, and I'm just wondering if this is an unknown
I'm not going to
unknown.
say which it is.
But Mr. Secretary, if you
No,
believe,
I'm right here.
if you believe
I'm right
something,
here.
Okay. So there's everybody knows the Mona Lisa. There's a difference between, a very strong difference between a painting, for example, and a typeface. And everybody thinks like the Mona Lisa is there forever, but basically the Mona Lisa is dead. Like it's just hanging there on the wall, and it's slowly like waiting to die. Well, if you compare it to a font, like what Francesco Grifo made 500 years ago, like it's still very much alive. His idea is still alive. So maybe that's there on the phone in a bimbo. So basically, if you compare a typeface to a painting, then the painting has one life, and it has reached its max, and it's just waiting for its death. And the typeface, I don't know, like it maybe is immortal, like it can live forever.
And that's very interesting, because if you look at this term revival, then I believe that this is a term which is really connected only to typefaces. If you think about it, like books or theater plays or fashion or a painting cannot be revival, but a typeface can be. And this, I think, is a very big difference between typefaces and all other cultural disciplines.
So imagine a cat has 9 lives, then fonts will be immortal. And what does it mean for you if you already know that the fonts which you make today, that they will be immortal in the future? Like, what does it mean? Like, do you have to take this into consideration while designing fonts now? So instead of making, like, one day somebody will make a revival, but maybe you don't want to make, you want to be ahead of this.
So instead of only thinking and be like focused on revivals, perhaps we have to take this 21st perspective of the pre-thinking, and instead of a revival, we also have to previval.
Okay. Half an hour, we still didn't show any font at all. That's good. Therefore, we've been thinking about this, and therefore we want to introduce a new term today. It's called font fiction. And basically what we have with font fiction is that we should start thinking about today already about how our fonts which we create today, that we prepare them already for the future. And everybody who leaves the room after Lucas' lecture, he will get a small booklet. So you don't have to write everything down. You can just read it here. And if you miss the book because they're out of print, then we also made a website, fontfiction.com, where you can just read everything. Okay. It's no reason to take pictures or notes. Everything is there.
So the basic idea within font fiction is like based on those different dimensions wherein we are working. So, as mentioned, there's this dimension of reality, and there is this dimension of imagination, and the third one is the inconceivable. And the idea is that with font fiction, we take all those dimensions into consideration in the working process. So instead of like what, for example, science fiction is doing, like to relate to the future or to bring the future to the present, what we try to do is to bring the present to the future.
Yeah. And you should also do it.
So basically it's about designing tomorrow's fonts today. And so how to put this idea into practice? We have like now 3 little examples. So the first one would be based on the reality where we are in and to reflect on the situation. And if you look like what's happening at the moment, there is a very big change from static to dynamic. And probably this change is much, much bigger than we are aware yet or that we can realize. Because basically the design changes from this to that. And in that way, I also believe that the 20th century was about contours, and we are still stuck with the idea of these contours, but probably like verbal fonts are not about contours, but are about interpolations.
So basically, we should not be designing outlines anymore, but we should be designing interpolations, and then the outlines will be a result of this interpolation. So basically, these lines, that's the thing what we're designing. And we're having a problem with these lines, because everybody can see that it's very limited, like every line is straight.
So in that way, perhaps we are at the same moment than 50 years back when the first people designed like fonts on the computer and they were only allowed to use straight lines. Because the ones who made the techniques, they said like, yeah, you cannot use round lines because this is too complex for our computers they had then 50 years ago. So the revolution or the problem, the type design problem of the 20th century, like the digital type design problem, was probably to get those straight lines like rounded. And in that perspective, you could also say that the 21st century type design problem is to get our interpolations rounded.
Yeah, and I think it's more important because with verbal fonts, everything, like interpolation is like, the whole thing is just an interpolation, so we should reevaluate the current state, how we interpolate things, and see, like, this is the good moment to see, like, if this should not have a different approach. So that's what we want. We want to have those nicely round curves, not only for the outlines, but for the interpolation itself as well. And you think, like, why do I need this? Now, we have a couple of examples, like, why it really makes sense.
But perhaps it's really important to realize that there happened like one more abstraction layer on top of what we did until now. Because until now, we designed points which then created outlines. But what we are doing now is we design interpolations, and they define our points, and those points define our outlines. So in that way, it's important to realize this new layer of abstraction. But like, for example, this is the problem if you want to rotate something like 180 degrees. Then we end up with that, because this is what we got as interpolation.
Yeah, and then of course you can solve it. You can say like, oh, then I just make another master there and then get this. But still, this is not what you want, because if you want to have a nicely rotating rectangle, and of course you can solve it then by having many intermediate masters there, like putting 20 or 100, like to make it look like it's round. But it's still like, basically it's still doing the same thing there. This is not what we want. What we actually want is to have a rectangle which is just rotating nicely around the curve. So this, basically what you actually want is only these two masters going from there to there without morphing.
And we were talking with lots of people like the last half year, and everybody said like, yeah, this is a problem, but still, you know, like, we just have to accept the problem because there's no solution for it. But then again, we looked like at the stuff what we showed last year, and there we stated that within this font, what we showed last year, the Superfont, that there's everything inside. So if this is true, what we said 1 year ago, then this would also mean that there has to be somewhere within the Superfont also something called like a nonlinear interpolation.
Yeah, there was a little misconception about the Superfont. People thought like we put the whole library into a font, but it was not our library, it was all the fonts, also your fonts, every font ever made was in there already. So it's not just a library which is in there, it's all the fonts ever made, and also all the fonts which you will ever make, we will ever make, are already in there. So that's the concept of the Superfont.
So once we looked at it again, and we looked very carefully how these points move by playing around with this Superfont, we could see something like that those points were not moving on lines, but those points were actually moving on curves. So we said, like, okay, if this is inside, we just have to understand like how this is possible and how to extract that for our nonlinear interpolation, what we really need and what we want.
And that's the moment where we found out about higher order interpolation. And basically, a higher order interpolation, it sounds a little bit complicated, but it's the principle is related to making outlines, Bézier curves or quadratic curves. So if you have a quadratic curve, everybody probably knows it, but to understand the principle of higher order interpolation, we just quickly show it. What happens with a quadratic curve, you go from A to C, and then at the same time you go from C to B, and you get a traveling line which travels from A to C and also to CB. And then if that's on 40% there from A to C, and then 40% from C to B, then if you put a point of 40% on a traveling line, then that point is exactly on the curve. So this is the very basic principle of a quadratic curve.
So if you look at it like this, we actually see like 3 straight lines. And in that way, it should be possible to get this into our design space quite easily. The thing with the higher order interpolation is that perhaps how it works is a bit complex, but how you can apply it is very simple. So if you look at it, you see this curve. I think the first trick you have to do is not look at the curve, but look at those straight lines, what Bas just explained. And then the only thing what we have to do is we have to get those straight lines into our design space. And that's rather simple, because we have the connection A to C, we put it here. And then we also need this other connection, C to B, and we just put it parallel with it on top.
Yeah. So the trick is like to translate a curve into a design space. That's still understandable, no? That's yeah, okay.
So in that way, we have this very simple design space with 3 masters. And this is not a mistake that there's like twice the same masters, because in that way it creates like this kind of parallel design space with what we call also Guillemot space. And by doing that, we actually have this movement of A to C and C to B at the same moment by moving on one axis. And so if you do this, you can also see that this new line, what we need to create our curve, gets created by this orange line. And because this is all like, again, 40%, we have to go 40% up. And so if you do this, you can see that we just need to have this diagonal.
But you should be aware that the diagonal from A to B looks like a straight line, but it is a curve.
And we call...
Yeah? Okay, that's okay. Everybody's still in.
So this line we call the desire path. That's like, this ways people just choose and create because it's the best route you can take. And it's not using the official roads, but it's creating your own road. And this desire path can be very easily achieved by, if we go back to the design space, like we see we have these 2 movements. So one is going from left to right, from bottom to up. So you see there's one slider, and the next slider goes from left to right. And because we want to have this diagonal, it's very simple. What we have to do, what we have to introduce is something called a master slider. A master slider is just like a slider which is telling all the slaves what to do. The slaves just follow what the master slider is doing. And if you use this, again, for the design space, you get this, that the master slider is just taking care on the other 2 sliders, and we have exactly our desire path. And here you see the design space, and that actually creates exactly like the point on the curve.
Okay. Sounds nice. and you think, okay, but what is it? Is it good for anything at all? It could make sense. Like we have a shape here. Like we have two masters. Like one is a rectangle at the bottom, like shape A, and then there's shape B. And now we want to interpolate from shape A into shape B. And with the linear interpolation, like shape A looks nice, shape B looks nice, but everything in between is not what we want. Maybe we want something which is bending around the curve. So with linear interpolation, you cannot achieve this, but with higher order interpolation, like this, something like this will be possible. This is not like this is like a real interpolation in a font. It's not a keynote which we fake somewhere. But there you can see that then you have to start designing those orange curves there on the right. So suddenly you're designing those interpolation curves instead of just accepting them as linear interpolations.
And of course, for the people who look carefully, they realized that actually we are not designing with quadratic, but with cubic curves, but it's actually the same principle. So if we have the curves, what we use, like in our font design programs, it's actually the same. You know, the Bézier curve is created by 40, 40, 40, and so on, and the new straight lines are created. Again, these straight lines, we go 40%. This creates the final line, and on this line, we go 40%. Yeah. If you translate this to the design space, it's...
Wait. So this is important to remember that basically this cubic curve is exactly the same as the quadratic curve, only one order higher. So we have the quadratic curve, and then go one order higher with one extra step, you get to a cubic curve.
So it's, again, straight lines. And we can just put those straight lines in our design space, and which looks like this. So basically it's a cube. And again, there's now there's even one master represented at 3 locations. As you can see, C and D is represented on 3 locations in the design space.
It's very hard to see on the screen, I think, but if you look closely on the right, it should not be a rectangle, but it should be a cube. On the background, on the right top, you can still see a B, I think, but they should also, you should see a D and a C and a D there on the back as well. So again, you have this rectangle, the design space has a rectangle. If you take it one order higher, this rectangle becomes a cube, and then you end up, it's hardly visible, but it should be a cube there on the right. And exactly the same process, if you then take the desired path, you take the shortest route from A to B, you will end up again with a straight line through the cube. And the straight line through the cube means that all the interpolations happen at the same time, so they are parallel. So again, this is a parallel design space, a Gamow space, with a master slider, which if you move it, all the other sliders follow along. So basically this cube, what you see here, it represents a kind of design space, but it represents a cubic interpolation. So if you put your masters in that way in your design space, you will get exactly the curve what we just showed, the example what we just showed. But if you go from the second order, from the quadratic curve to the cubic curve, or cubic design space, you can also go another order higher.
Because the problem is, when we want to make this concept really, really good, we should not have any limits. So right now, we can only make one curve. But what happens if you have something like this, like a more complex curve? Because we should have no restrictions. And then we were the type design paradigm is, of course, put as little points as possible. So we need to have, in the space where we design normally in font programs, we would need those points to design this curve, on the extremes. But if we would try to translate that to our cubic, to our higher interpolation cube, the problem would be that we would end up with something like this. And you can already see that this looks very, very messy. Because what this actually means, what you see on the left, is that there is a kind of, the cube is representing a normal curve, and those points there in between are representing extra points. So this is something like this, and this is very, very bad.
If you draw type, you will never draw a curve with so many points, because if you change one point, basically you want to change the curve, so means you also have to change all the other points on the curve. So basically, you always tell, yeah, we only have a beginning point and end point, and the rest should just be a curve. So if I want to change this curve, like I'm not depending on all the other points which are in between. So basically, you only want to have a begin point and an end point.
So therefore, what you have to do is you have to get rid of these points on the curve. And that's very simple, because therefore the whole thing is called high order interpolation. We just have to go a higher order. And there you see that if we go a higher order, we have more off-curve points. And this is like a contour on like a 7th order contour. Can you see? Yeah. Yeah. And this 7th order contour is actually drawing exactly this line, this curved line.
So what's important to remember here is like you only have one begin point and one end point, and there are no other points on this line. So you only have 2 points there on the line, and all the other points are off curves. And you still basically you can make any shape, or the line can have any shape. Like now it's like a kind of inflected thing there, like a wobbly thing. It could be anything.
So in that way, we can finally use like a nonlinear interpolation without any restrictions. But
you don't have to write it down. We wrote it down for you. If you go to our blog, you will see a small text trying to describe the same principle here.
But if you go further, like what we just showed was the 7th dimension, or 7th order, I should say. Like if you go higher, like for example, let's say the 14th order, and you see like what's happening there, it's quite interesting, because once you are like really in like higher orders, we can actually draw whole ladder shapes just with one point, like with a starting point and an end point. And here also you can see like how this is then created by this calculation.
So basically you could design fonts with only a begin point and an end point maybe.
So in that way, here we see also our next problem, what we have to solve, because what we have to really solve is to get rid of the points.
That's for next century. We can imagine things which are not there yet, but we also know that we cannot imagine things which are not there yet, but which will come. Sounds a bit abstract, but there have been many examples in the past where people invented things which didn't exist, and basically they couldn't imagine it, but somehow they created it, and then only later on somebody else realized this idea. So already in 1932, or maybe in the 20s already, somebody basically invented the internet. There was no computer at all, but Paulo Let, he made this whole system of cards, small cards, and basically it's a description of everything, and it already had hyperlinks in there on these cards. So if you had a dog, then the card of the dog would have a link, like a kind of a tag or hyperlink to another animal. It's a massive archive of small cards. He already invented the internet without any computer at all. The variable fonts, we think it's very new, but the concept is already 90 years old.
Like the first mentioning of variable fonts dates from indeed 1928 in this book from Walter Benjamin. He uses also the term.
So they already imagined things they couldn't realize at that time when they were living, which we have now. So basically we should also be able to imagine things which will not happen in our lives, which we have to prepare ourselves for. So if we want to prepare our own fonts, like we should not limit ourselves to the current technology. So finally we show a font. This is a variable version of Duos. Duos is the script font which we released some months ago, and there's a variable version, and you can see like the weight can change, the inlines can change, like it can do many things. But there's a problem with having an inline in this connecting script currently with current technology. And I think it's pretty clear to see here, like there's one version here of the font which has problems there because this has some ligatures to make the connection smoothly between one letter and another letter. But this has like 80 ligatures or 79 ligatures. The other version has 1,000 ligatures. And there you can see the difference. Like some words, then suddenly they have a gap there because it doesn't connect, because it doesn't have a ligature. And the other one, they smoothly connect. And basically, you don't want to make these ligatures at all. Basically, it's a limitation of current technology. Basically, yeah.
Yeah, and the whole thing, of course, gets even more complex if you say, like, I would like to have my inline not linear, but perhaps I want to have it like a variable, that it goes thicker and thinner. So in that way, that's really a limitation of what we can do at the moment. So the problem is the technology.
Yeah, so basically what you want, you say you want to have a paragraph of text, and then when the black text is set, then you want to apply like the inline maybe, and then you can still have options for the inline.
So the problem is that this font math, what we are doing now is we just have our UFO, and this we have our online, we have our own tool, like design tool. With this design tool, we generate the variable font, and then this variable font is sent to the user, and he uses it to generate a document. And there the font math is done at our desk, and that's very much a limitation, because what you really would like to have is to have the font math to be made at the user. So basically what we do is we just make our UFO, and we make something like a smart font, and within the smart font, the plugin, the tool, what we created is included, and this tool can then be used by the user in his design environment by working with it. So you have the font, and then this tool, which is built inside the font, creates something like a hypervariable font. And this hypervariable font, which is not really existing, generates the final text, which is rendered at the document, which looks like that. And now it gets difficult, because how can you make that? How can you build that? Like, we don't have the technology, and we don't know how this technology should work. So in that way, it's difficult to export that, to make it possible. But at the same moment, there is, of course, language. And the nice thing is in language is that it allows us to do things which do not exist.
So we know what we want to make with this variable version of Duos, but we cannot do it. But we can at least describe, we can tell you what we wanted to do, but we cannot build it technically at the moment. It doesn't. But in the future, it might be possible. But maybe we are not there anymore. And then it would be a pity, like if somebody would then make a revival of this variable version of Duos, and then he would make the wrong version. So we should prepare those people when we are not there anymore, that in case somebody ever makes a revival of Duos variable, that he makes the right kind of revival, what we imagined already now.
So we just put all those things, what we wanted to do but could not do, in a text. And this text we just save as a simple text file on our desktop. And then we use SMT edit. And then we just use this little text and append it as a font table to our font. And in that way, we pre-rivaled our typeface to make sure that like future generations will know what to do. So just imagine that like 50 years from now or 40 years from now, there's somebody who discovers our font in an archive, and then he would TTX it. He would see that. So, and then he would be, of course, curious, like, what's this fofi? And then if he would look at this fofi and open it, and in his program, he would discover that, which are actually all the instructions what to do. So if sci-fi is about a speculative fiction, then fofi is about speculative instructions.
So this is, we have the reality, the dimension which we live in now. We have another dimension which are things which we can imagine, which we cannot realize, and then there's a third dimension of everything which is outside there. With last example, we can show something for this last dimension.
At home. never dreamed the likes of this. That's beside the point. The issues at hand are other things. This is not going to be a song and dance. That's entertainment. Another thing. All together. This is something I came upon while walking in the woods. That's ground for thinking through other things.
Of course, the unconceivable is the most like abstract and esoteric dimension. And so we discovered this movie from Gary Hill, who was like telling like thinking through things. I'm not sure like what this really means or how this should function. But what I know is that the font what we showed like last year, this the Superfont, we also created a version which is like actually speaking to itself. So what it does is like once you have a sound, the letter gets deformed, and while the letter gets deformed, it's again starting to speak, and because it's speaking, it's again like getting deformed, and because it's getting deformed, it's speaking again.
So basically this is a typeface which is speaking to itself all the time. It's having a dialogue with itself.
And then you have this typeface which is speaking to itself, and then you wonder like, what is this thing about, and what should you do with that? So in that way, we had Gary Hill who was saying like thinking through things. So we thought like, okay, let's just give him the typeface and see what's going on.
No, we're not. No, we're not. We're not. We're not. We're not.
So it's very difficult to get the meaning of that all, but I think what's interesting is also what Gary Hill then once said. And so in that way, I think it's like we can summarize that font fiction is about this three dimensions, about the known knowns, about the known unknowns, and about the unknown unknowns. And then there's only one last question, like which dimension was Donald Rumsfeld in? And the interesting thing is that basically he was in this movie, he was telling about those three dimensions. And then later on, I think 5 years later, a movie was made about him because this statement became very like known, and like it was, people found it very interesting, this statement. But so let's show a little clip from this movie.
You want me to read this?
Yes, please.
February 4th, 2004. Subject: what you know. There are known knowns. There are known unknowns. there are unknown unknowns. But there are also unknown knowns. That is to say, things that you think you know that it turns out you did not.
So we thought like this.
Thank you.